In this video, we're going to discuss the three-dimensional coordinate system. And in particular, we want to discuss how to draw the three-dimensional coordinate system and then how to plot a point in that system and how to draw some specific types of surfaces in 3 dimensions. Except when we're drawing this, we're drawing it on a piece of paper, which is inherently 2 dimensions. So we'll go through some techniques on how to draw these 3-dimensional figures on 2-dimensional space. This is important because throughout this semester we're going to be dealing with 3-dimensional objects, and we want to be able to visualize these objects and understand what their properties are, and then be able to translate that into a 2-dimensional drawing. So let's get started. We have a picture here of our coordinate system in 3 dimensions. Generally, we draw the x-axis in a 45-degree angle down and left. This is the positive x direction. Our positive y direction is here, which is drawn to the right but slightly down from horizontal. And then the positive z direction is straight up. Now we could orient this really any way we wish, as long as we follow something called the right hand rule, which is if you hold your right hand like this, as shown in this picture, your thumb will point in the positive z direction, your arm will point in the positive y direction, and your fingers will curl towards the positive x direction. So no matter how you orient your right hand, as long as when you do that, your thumb is the positive z, your arm is positive y, and your fingers curl towards positive x direction, you will be consistent, and everything will be fine. So this is how we draw our standard coordinate system with z straight up and x in this direction, y here. We also have a picture here of a few planes in our 3-dimensional coordinate system. In particular, if we think of our 2-dimensional coordinate system, generally when we have a graph that we're trying to place in 2 dimensions, that graph ends up being a line, which is a 1-dimensional object placed into 2 dimensions. In this class, if we're dealing with graphing in 3 dimensions, a lot of the times we're going to be graphing surfaces. A plane is a type of surface. So this green plane here is the YZ plane, which occurs when x is 0. This orange plane is the XZ plane, which occurs when y is 0. And the blue plane is the XY plane, which occurs when z is 0. And planes are a particular type of surface that will show up in this class. We will, much later in the class, also be talking about lines in 3 dimensions. So you can think about a string that is twirled around in 3-dimensional space. So we'll also discuss objects like that. But for right now, we just want to learn how to draw points and then some surfaces in 3-dimensional space. So let's get started with that. All right, so we're going to plot the point 2, 1, -3. For clarification, this first coordinate is x. Okay. And then the second is y, and the third is our z coordinate. So let's go ahead and draw our axes. So this is positive z, positive x, positive y. Okay. And if you look back up here at this picture, this gives us an idea of how we want to draw a point in 3 dimensions. What we can do is we can build a rectangle, and the point that we want to draw, sorry, not a rectangle, a 3-dimensional rectangular prism, and the point we want to draw, P, is going to be at the opposite corner of this rectangular prism from the origin. Okay, so let's do that. And first, how might we do that? Well, all right, x is 2, so I'm going to do 1, 2. We have a point there. That's going to be this corner of the rectangular prism. Let's see, y is 1, so let's move there. And that'll be this point of the rectangular prism. Then z is -3, so we're going to go down 1, 2, 3. In this picture up here, that's actually this point on the rectangular prism, so the point on the z-axis that is not the origin. Just in this particular problem, we're going down instead of up. Okay, so how do we actually draw all of this? Well, let's take those first 2 points and let's build a rectangle. So I've drawn a rectangle now using those first 2 points. The 2, 0, 0 and the 0, 1, 0. And then we want to translate that rectangle down and do the same thing, but we started at the origin before, and now we're going to start at 0, 0, -3, that point along the z-axis. So we're going to draw that same rectangle now. And we drew that same exact rectangle, and if we connect these points, we now have a rectangular prism, and our point that we plotted is the one that is opposite of the origin within this rectangular prism. Right, here's our origin, and so here's our point. So if we ever want to draw an individual point in 3 dimensions, this is how we do that. And so this is the point 2, 1, -3. All right. The second part of this says find the projection of P onto the xy plane, the xz plane, and the yz plane. The projection here means that, well, one way we can think about this is if we shined a light, if we were going to the xy plane, if we shined a light straight up into the xy plane, where would that shadow of that point end up? So, how can we do that? Well, the projection onto the xy plane, the projection onto the xy plane here is, and that point would be, well, it's this point, 2, 1, -3, except z is 0 here, right? Because our xy plane occurs when z equals 0. So this is just 2, 1, 0. The xz plane is the point, well, the xz plane occurs when y is 0, so it's that same point except when y is 0. So that's 2, 0, -3. And the yz plane is, well, this occurs when x is 0, so 0, 1, -3. In the picture that is, this point, and this point in particular are those 3 points. All right. And let's see here. Okay, so the next thing we want to do is get some practice drawing some surfaces. In particular, these 3 surfaces. Oh, there we go. In particular, these 3 surfaces. So let's do that. Draw our coordinate system again. Positive x, positive y, positive z. We want to sketch the surface x equals 1. Well, if x equals 1, notice that y and z are not in this equation, so those are allowed to be anything. So let's draw the x equals 1 tick mark. And since y and z can be anything, this ends up being a plane that runs through this point and is parallel to the YZ plane. Well, if we go back up here, the YZ plane is this green one. So we want to draw that plane, except moved away from the x equals 0 mark and move to the x equals 1 mark. So we just want to move this plane forward 1 unit. So that's what we want to draw. And to do that, our boundaries of this plane, we want to draw parallel to the z-axis and parallel to this y-axis. Oh, no, it should be straight down. And there, we have drawn a plane that goes through x equals 1. We can do that really quickly for the other 2. We also have y equals -2 and z equals -5. So y equals -2. We want to go into the negative y direction now. So let's go -1, -2. And now we want to make a plane that is parallel to the xz plane. Oops. Well, let's just do this. I'll draw 3 lines. That should be straight up and down. Not drawing this very well. There we go. And we have a plane here going through y equals -2. And we can do the same thing over here for z equals -5. So -1, 2, 3, 4, 5. And again, now we want to be, this is a plane that will be parallel to the xy plane, just moved 5 units downward. So let's draw a plane parallel to this xy plane. And that is here. And of course, these planes extend forever in these directions, but we can't draw that, so we're just going to draw that square. All right, and that's it. We have a remark down here that essentially says what I'd said earlier. In particular, when x equals 0, this represents the YZ plane, and so on. So read through that remark, but we've kind of already discussed that information. In this video, I'm also going to go ahead and draw a few more surfaces, and then we'll split up the video and do the rest of this section on a second video, because this is already getting kind of long. So let's draw a few other pictures real quick. So now we want to sketch surfaces in R3, represented by the following equations. Well, let's start with the x plus y equals 1 equation. Well, this is a plane, so how do we best draw that? If x plus y is 1, that means z can be anything. So we're going to essentially ignore z for the time being. So x plus y is equal to 1. So let's suppose that x was 0. If x was 0, then y was 1. Well, if y is 0, then x is 1. And we have that point. So we have the x plus y equals 1 line. That is within our plane, so we can draw that. Okay, what else? Well, since z can be anything, z could also be 1. This line that we drew here is z equals 0. So z could also be 1. So let's draw this line as well. What are these 2 points? Well, this point is when is x equals 0, y equals 1, and z equals 1. This is x equals 1, y equals 0, z equals 1. So we also have that point. Now let's see, if z equals 2, then we can draw those points as well and draw the line between there. That line is also in this plane. And so we can do that a bunch of times and come up with the plane that passes through, or that is represented by this equation, x plus y is equal to 1. And of course, we could keep going, and this plane would extend forever downward and upward and off to the sides. But that's our plane. And all of these lines are just lines that are within that plane. We can do a similar thing here. Oh, Z. Oh, I can't draw. Let's straight up. All right, and so x plus y plus z is equal to 1 now. Well, if x and y are 0, then z equals 1. So we can plot that. If x and z are 0, then y is 1. If y and z are 0, then x is 1. So all 3 of those points are in this plane. Let's see if we can get a few more. So these are all in the plane. And let's see if we get a few more. What happens if x is 2? And suppose y is 0. If x is 2, y is 0, that means z is negative 1. So x is 2, y is 0, so we don't move left or right, and then y is negative 1, so we're down here. If y is 2 and x is 0, then again z is negative 1. So we also have some points down here. And let's see. We can just keep drawing that. And so we have a plane that this triangle, or these 2 triangles, are in. And we might be able to just represent that plane in this way. But we can just think of a piece of paper that follows this triangle, or that triangle lies within. And that's another way we can try to draw these planes. if we're just looking for portions of our surface. All right, let's do a couple more here. X squared plus y squared is equal to 1 is a circular cylinder. We're going, in a later section, we're going to be discussing cylinders in more depth. But let's go ahead and draw a picture of these real quick. First off, x squared plus y squared is equal to 1 is a circle. So we have a circle here. And that is a circle in 2 dimensions, but we're in a 3-dimensional space. Z can be anything, so what is this going to be? This is going to be a cylinder centered along the z-axis. So we also have another circle up here, and then centered along the z-axis, so we have another circle down here. And we get a cylinder, just like that. We also have something called a parabolic cylinder. So this is an example of that, is the equation z is equal to x squared. So we say parabolic cylinder because, y equals x squared is a parabola in 2 dimensions. This is z equals x squared, so this is now a parabola in the xz plane. So let's draw a parabola in the xz plane. But y is not in this equation, so y can be anything. So we're going to have another parabola over here. And all of them in between, and then another parabola out here. If I extend this y-axis, goes through that point there. We draw a parabola, and we get a parabolic cylinder, parabolic cylinder here. Which, if you're trying to visualize this, if you think about any of the Olympic sports, you think about like the half pipe for snowboarding or skiing, this is that kind of shape, that half pipe shape. All right, real quick, these last 3. X squared plus y squared plus z squared is equal to 1 is a sphere. So I can draw that circle that I did earlier. But then we also have a circle in this direction as well. So we can draw our sphere. Probably should use dotted lines for the back part of the sphere. But we can attempt to draw our sphere here. I'm not the greatest artist, but I will do my best. So we have a sphere of radius 1 here. Z squared is equal to x squared plus y squared is an example of a cone. And that would look like this, with circles centered around this z-axis. And so on. And really, since it's z squared is equal to x squared plus y squared, we have the same cone running down as well. All right, those are supposed to be symmetric on either side of the XY plane. And then, let's see here. For the z equals x squared plus y squared paraboloid, this is a very similar thing as the cone, except instead of straight lines here, it's more of a parabola shape. Let's see if I drew that correctly. I might need practice here too. I did practice these ahead of these videos, but it's still difficult. In fact, I messed up there. Let's not do that. I will draw that again. See, we all make mistakes when we're doing this. This is not easy. So let's draw small circle here. We can draw some bigger circles up here. I am not doing this very well. This is actually where I wanted to end the video anyways. So we have still several more things to do in this particular video for this section. So let's actually end the video here, and I'm going to go back and practice this and do that better for the next video. Sorry about that. But that ends our first video for this class.